Folks, this is Mr. Vass here. Welcome back for another installment of my award-winning videos. This one kicks off Math 172, the pre-calculus course that we're starting here in the second semester. Section 10.1 starts with a subject matter of angles and their measure. You'll notice that the notes are all filled out here. I'm not going to complete those in this video because we did them in class. I'm just going to hit some of the highlights and then show you a couple extra examples. So the first thing is that we have here is a review of some definitions from geometry. I'm going to let you go ahead and pause the video if you need to review those on your own. Otherwise, I'm going to scroll down here to some new vocabulary. Okay, new vocabulary that I want to highlight for you is the idea of degrees and minutes and seconds and the DMS system of measuring angles. So a degree is a pretty small unit of measurement for an angle. But we can split that up even further, and we can split 1 degree up into 60 minutes, and then we can split 1 minute up into 60 seconds. So that's just a way to further subdivide an angle, and the symbols that are used are a single apostrophe for minutes and a double apostrophe for seconds. This little conversion here is just shows you that 1 degree equals 3,600 seconds. That's because 60 times 60 is 3,600. Another piece of information here, we're going to use this terminology throughout the rest of this semester. The initial side of an angle will typically be the side that we lay along the positive x-axis. The terminal side of the angle is the side that we measure to. Positive angles are measured counterclockwise, and negative angles are measured counterclockwise. Here's some more definitions for you: standard position, quadrantal angle, coterminal angles. I'll let you go ahead and review those on your own, but the one piece I really do want to highlight here is this idea of coterminal angles. They're angles in standard position that share the same terminal side. So basically they're the same angle, they just might wrap around a circle more than one time, or rotate around a circle more than one time. So alpha and beta can be coterminal if and only if beta equals alpha plus 360 degrees times k, where k is any integer. And I'm highlighting this notation because you're going to see it a lot this semester, where we're starting our study of trigonometry, and we're going to notice that things are repetitive. They're cyclical in nature in trig. So how do things repeat? Well, they repeat as we take this integer and we index it from, let's say, 0 to 1 to 2 to 3 to 4, etc. So k for the rest of the semester represents any integer. Don't forget, integers can be positive or negative. An example of what I just talked about is here in example 1. What does a 450 degree angle look like? Well, it's a 360 degree angle plus another 90. So a 450 degree angle is coterminal with a 90 degree angle. And again, that's just using our new vocabulary term of coterminal. Okay, so that's a quick review of side 1 of the notes. Now I'm going to flip to side 2 here. Again, it is already filled in because we've done this in class. I'm going to give you just some brief highlights here. Example 3 and 4 go through converting from degrees to the DMS system, degrees, minutes, and seconds, and from DMS to degrees. There are a couple examples in WebAssign, so it's in your best interest to take a look at those 2 examples. Make sure you understand how they work. If not, go ahead and ask me a question. So now I'd like to move into a discussion of circumference, diameter, radius, pi, and radians. This is probably one of the most important things to take away from this lesson, and the reason why it's so important is because we're going to rely on it as kind of our new language for the rest of the semester. Most of the stuff in here you already know, or at least I expect you to already know. I do expect you to know that the circumference, or the distance around a circle, is the circumference is the distance around a circle. I expect you to know that the diameter is the distance across the circle through the center. I expect you to know that the radius is half the diameter. So what is pi? Well, pi is the ratio ratio is a comparison of two numbers of the circumference of a circle to its diameter. So this is again something I expect you to know. You may have seen this written in a different form. You may have seen it written like this: circumference equals pi times diameter. That's the formula for circumference. You can also say that circumference is 2 pi r. That's another formula you will see for circumference, and that's because the diameter is half the radius. The diameter is double the radius. So you double the radius to get the diameter. Please do me a favor. Do not confuse circumference equals 2 pi r with this, pi r squared. That is totally wrong. Circumference does not equal pi r squared, and students continue to find this confusing because if you look at this formula, you got 2 pi r, you also got a 2 and a pi and an r in there, but they're not the same thing. The 2 is in a different place, and that different place is critical. Okay, so circumference does not equal pi r squared. Hopefully you are screaming at your computer saying, Mr. Bass, it's area. Area is pi r squared, so the area of a circle is pi r squared. Please don't get those two confused. It's worth me spending a couple extra minutes here screaming at the computer to remind you that those two things are really important to keep separate. As I alluded to in class, we have a new angle measurement, and it's now called a radian. And I've given you a couple conversion factors here. 180 degrees equals pi radians. And the degree to radian conversion is you take the number of degrees and you multiply by pi over 180. If you want to convert from radians to degrees, you multiply by 180 over pi. This picture illustrates what a radian is. The ratio of a arc length s to the radius of the circle. So that theta, that angle theta in radians, is the ratio of s to r. And both s and r are lengths. They are measured in inches or feet or miles or kilometers or centimeters or angstroms or whatever unit of length you choose to use. And when you take a length and you divide it by another length, you get a dimensionless unit. So radians have no dimensions. They are just a ratio of two numbers. And I'd like to flip to the next slide right now, where I'm going to show you what I believe to be kind of the best illustration of radians that I've ever seen, and hopefully you'll agree. Okay, so what the heck is a radian? Well, we start with the radius of a circle, and there we see our circle in blue. Hey, look, there's our radius. Now, if we take that radius and we wrap it around the circle, the angle that creates is 1 radian. Because the ratio of that arc length, to the radius was 1. As you take and you look at 3 radians, oh, look at that, 3.14 radians, or pi radians, is halfway around the circle. The rest of the way around the circle is 2 pi radians. Does that make sense? Well, I certainly hope it does. Remember, we said theta equals s over r, the ratio of the arc length to the radius. We also said that circumference equals 2 pi r. Okay, so if we look at the ratio of circumference to the radius, it equals 2 pi. And the circumference is all the way around the circle, so that better be an angle measurement of 2 pi. Okay. I'm going to flip back here to finish up some things on this page for you. And in example 5, you'll see that I've identified some key points on this circle. These represent special central angles, and we've talked about these in class. We have pi over 6, pi over 4, pi over 3, pi over 2, and then there are multiples the rest of the way around the circle. In example 6, I've looked at an angle alpha of -5 pi over 3 and asked you to come up with a couple equivalent angles to that. This one looks like it got chopped off by my hole punch. So if we have negative 5 pi over 3 plus 6 pi over 3, that gives us just pi over 3. Okay, so these two other angles are the same. They are coterminal with negative 5 pi over 3. And notice, negative 5 pi over 3 was measured in the negative direction, so we go clockwise. 1, 2, 3, 4, 5/3, negative 5 pi over 3. Okay, I'm going to go ahead and stop this video, and I have a little supplement to this I'm going to do to show you a couple extra example problems you'll need for WebAssign.